Okay, good day. Today, let's take a look at the instruments and yes, materials utilized in clinical microscopy. Okay, first on the list is your clinical centrifuge. Okay, and so as you all know, your clinical centrifuge separates solid materials from liquid material through the application of gravitational force by rapid rotation or spinning. And yes, these materials are separated based, of course, on their density. Okay, and so aside from that, I mean, for this one, it recovers materials from a suspension, like for example, in case of your urine. Okay, and so there are suspended materials present in the urine that, in turn, after centrifugation, uh, we get the sediment and examine it microscopically. Okay, and so in hematology and other areas of the clinical laboratory, this one is utilized to separate plasma or serum from cells in your blood specimen. Okay, and so after the centrifugation, you have what you call as your precipitate and your supernatant. The precipitate, that is the solid material that is packed at the bottom of the centrifuge, or otherwise we call it as the sediment. And the supernatant is the liquid portion. Okay, and so again, as for clinical microscopy, it prepares your clinical centrifuge prepares urinary sediments for microscopic examination. Okay, so yes, that is for your clinical centrifuge. Moving on, this one is an illustration, I mean, of a clinical centrifuge. Okay, and so you have the different parts here. You have the lead, you have the rotor, you have the display, the controls, the housing, of course, your centrifuge tube, and others. Okay, and so parts of your clinical centrifuge. Okay. Just a few reminders on the use of your clinical centrifuge. Please note to always balance the tubes. Okay, and so unbalanced tubes accordingly may cause excessive vibration and uneven distribution of sediments in your sample. And yes, it may also cause breakages of your glasswares present. Okay, and so that is why you make sure that before starting or before centrifugation. Okay, and so you please make sure that you balance the tubes. Okay, and so make use of if you only have one, or what you call this odd numbers, you make use of an extra tube filled with water. Okay, and so tubes must be capped accordingly, okay, to avoid spillage and from aerosol formation that will be a source of biological hazard. And yes, okay, and so possible evaporation may occur if the tube is uncapped. Okay, and so yes, heat is generated during the spinning process, and it will cause evaporation of your liquid. Okay, you keep the cover glass closed at all times. Sorry, cover of your centrifuge closed at all times. No, even if it's not, uh, even if you're not using it. And yes, do not stop the centrifuge with your bare hands. With your hands, you let your machine stop by itself. Okay, and so for that one. Accordingly, your College of American Pathologists recommend your revolutions per minute of your centrifuge in the clinical chemistry be checked every 3 months. Okay, and you make use of your photoelectric tachometer or your strobe tachometer to check this RPM, the RPM of your centrifuge, and also periodic checking of your timers and speed controls. Okay, and so yes, also you inspect your power cords, the lead lock, and internal components for damage. Also, you clean and disinfect the rotor and the chamber after use accordingly. Okay, and so you clean and disinfect the rotor and chamber after use. In case that daily, you clean and disinfect your centrifuge. And yes, in case that there is a spill, Okay, and so there that it should be cleaned immediately accordingly. And in cleaning and disinfecting, please consult your manufacturer's manual on this, because there are cleaning agents or disinfecting agents that may corrode the materials of your centrifuge. Okay, and yes, perform periodic lubrication and maintenance of your what you call this, of your centrifuge. Okay, and so again, every 3 months in clean cam, you what you call this, calibrate your speed or your revolutions per minute using your strobe tachometer or your photoelectric tachometer. And yes, once a year, you do your preventive maintenance uh by a professional. Okay. Okay, your urinometer. Your urinometer, this one is a weighted glass float with a long, narrow calibrated stem. Okay, and so please note on the image here. Okay, and so you have here a glass float. Okay, and so this one is your glass float, and this one is your calibrated stem. Okay, and so it is calibrated. And yes, this urinometer sinks, displacing a volume that is equal volume of the liquid equal to its weight. Okay, and so this one is usually calibrated with distilled water. Okay, and so usually calibrated with distilled water at 1.000. That is why when placed in a solution that with a greater density than water, okay, and so the urinometer accordingly displays as a smaller volume of liquid. And yes, it does not sink that deep. And yes, accordingly, the specific gravity read of the calibrated stem is greater than 1.000. Okay, and so of course, it is greater than water, distilled water. Okay. Okay, this one is an illustration of your urinometer again. Okay, and so please note that again in reading, you read at the lower meniscus accordingly. Okay, and so because your urine, this one is not a viscous fluid. Okay, and so your reading level, your specific gravity scale, of course, this is your graduated uh, long narrow tube accordingly. Your of course this one is your urine sample. Okay, and so as such. Okay, and so please note that again, your urinometer measures the specific gravity of your urine. And yes, and in your specific gravity, this one determines your specific gravity of your urine. This determines the kidney's ability to concentrate or dilute your urine. Okay, and so and in measuring your specific gravity, urinometer can be used to measure such accordingly. Okay, and so yes, please note that your urinometer uses 10 to 15 ml, okay, of urine. Okay, and so that is relatively large. It has a large, it requires a large volume. Okay, and yes, calibration is daily. Okay, and so it is the calibration is done daily, and also there are temperature corrections needed for this one. Okay, and so temperature corrections are needed again for your samples with temperature differences greater than 3 degrees Celsius from the calibrated temperature. Okay, and yes, also there is there are also corrections needed for glucose and protein. Accordingly, for each gram per dl of protein that is present, the specific gravity is increased by 0.003, while for each gram of glucose per dl, the specific gravity is increased by 0.004. Okay, and also please note that the float, sorry, should not touch the sides of the container, because if it touches the sides of the container, it will give you a not so reliable result. Okay, and so these are your disadvantages of your urinometer. Okay, and so large volume, daily calibration, temperature corrections, and corrections for glucose and protein accordingly. Again, for calibration, calibrated with your distilled water before use or daily, okay, and so at 1.000, okay, specific gravity. And yes, ensure that your urinometer is free from cracks and defects. And yes, maintain the testing temperature at room temperature again, okay. And so because beyond your testing temperature at 20 to 24 or 20 to 25 degrees Celsius, it will sorry, your testing temperature is at 20 to 25 degrees Celsius. Beyond this, okay, and so beyond this uh temperature, okay, and so you need to do your temperature corrections, okay. And yes, please also this one is uh is always is given, okay, and so to always clean your materials every after use, okay. And so for your urinometer, and yes, for this one you compare the results with another method like your refractometer, okay. And then your hemocytometer. Your hemocytometer, this one is a specialized slide that is used for cell counting with a microscope, okay. And so in the clinical microscopy section, this one, your hemocytometer is utilized in manual counting of cells present in your body fluids like your CSF, your serous fluids, as such accordingly. And yes, again, it provides you a somewhat precise count of your red cells, your white cells, and epithelial cells present in your body fluids. Okay. Okay, and so moving on, this one is an illustration of your hemocytometer. Okay, and so yes, you already know this. Okay, and so for this, of course, before you use, you inspect for it should be clean. Okay, and so before you use it, okay, and you make use of standardized pipettes and fluids that are accurate and designed for your type of cell count. Okay, for your what they call they say your hemocytometer. And yes, of course, you clean your hemocytometer every after use. Make use of a distilled water. Okay, and so to clean it. Okay, moving on to your refractometry. Again, so your refractometer, accordingly, your refractometer, this one is a laboratory material or equipment that measures the refractive index of urine to determine its specific gravity. Okay, and so it is accordingly better or more accurate than your urinometer. Okay, and so yes, your refractometry, this one is an indirect measure of specific gravity, and yes, it is based on the refractive index of light. Okay, and so accordingly, the light passes from the air into a solution at an angle, and the direction of the light beam is refracted and its speed is decreased accordingly. And yes, your refractive index, this one is the ratio of your light refraction in the two differing media. Okay, and so this one is an image of your refractometer. Okay, and so this area here is your sample plate. Okay, and so where you place your sample, put a drop of urine here. Okay, and then you replace the cover. Okay, and so that is for your parts. Okay, and so for this one, it should be calibrated using distilled water also, and it should read the specific gravity should read 1.000. And yes, always clean the prism and the glass surface after each use with lens tissue. Okay, and you ensure proper light source and avoid excessive ambient light interference accordingly. Okay, and so that is for your what they call this refractometer. Okay, and so again, daily calibration of this one, and you clean before and every after use. Okay, for your compound microscope, this one magnifies an object to a point that can be seen by the naked eye. Okay, and so because normally this objects, okay, and so examined under the microscope cannot be seen by the naked eye. But then with the aid of your microscope, you can already, okay, and so observe the object. Yes, and it consists of two magnifying lenses. You have your primary one, your objective lens, and then your uh, eyepiece or your ocular lens. Okay, in the field of clinical microscopy, magnifies urine sediments like your red cells, your white cells, your epithelial cells, your microorganisms like your bacteria, and then your crystals are also magnified, okay, and so observed in this one. Yes, it provides you a detailed examination of your biological fluid in case of your semen analysis, urine analysis, in the analysis of your CSF. And yes, with that detailed exam to provide or to assist in the diagnosis of diseases. And yes, okay, let's take a look at your parts. These are your parts of your microscope. Please note, okay, and so to make use of your adjustment knob or fine focus knob, adjustment knob, okay, and so or it is somewhat better than the focus. Okay, and so again, this one is to used or is used to view an object that are too small to be seen by the naked eye. Okay, and so when I say microscopy, that is the technique or the science of investigating its small objects using the microscopes. Okay, and so your microscopy, that is your technique, and the microscope, that is your object. Okay, and so let's just define a few terms here. Your what you call this, your total magnification, that is the magnification of your two lenses combined. Okay, and so let's take a look. Okay, and so because again you have two lenses, you have your objectives and your eyepiece. Okay, and so let's say, okay, and so when you make use of your low power objective at 10 times magnification, you multiply that one by your total magnification of your eyepiece. Usual for your eyepiece, you have 10 times magnification, 10 or 11, but then usually 10 times magnification. Okay, and so as for your resolution, it indicates how small and how close individual objects can be and still recognizable. Okay, and so that is otherwise known as your ability of a lens to distinguish between 2 points or objects as separate. Okay, and so your resolution or resolving power, this one depends, sorry, on the wavelength of the light that is used. No, okay, and the numerical aperture, it depends on two. You have the wavelength and the numerical aperture of the objective lens. Okay, and so accordingly, the greater the resolving power, the smaller the distance distinguished between two separate points. Okay, and your numerical aperture, that is your light gathering ability of a microscope objective. Okay, and so yes, let's take a look. Okay, and so for your working distance, if you make use of your 5 times magnification or your scanning, you have a working distance of 34 mm. Okay, and so it is somewhat far. Okay, and so it's not close. And then times 10, your low power at 4 mm, and then your 20, your 40 at high power. Okay, and so you have 20 mm working distance. Okay, and so that is relatively close. And then at 100 for your oil immersion objective at 13 mm. Okay, and so yes, there are distance. Okay, and so of course, okay, and so these are also set to protect also the microscopic slide. Okay, and so yes. Your numerical apertures typical for your objectives at scanning, you have a zero point 0.1 numerical aperture, and then at 10 your low power at 0.25, and then 40 or your high power at 0.65 numerical aperture value, and then 100 times magnification or your oil immersion objective at 1.25 numerical aperture. Okay, par-centered. Your par-centered, accordingly, this one is a term that describes your objectives that retain the same field of view when the user switches between magnifications. Okay, and so let's say, for example, when you switch between low power to high power, it retains the same field of view. Okay, and so it retains the same field of view, but then it was just enlarged. Okay, while for your parfocal, this one is a term for your objective lenses that remain in focus when the user switches from one objective to another of a differing magnification. Okay, and so it remains in focus. Usual po, a technical tip for this one is you start with a lower magnification objective, and then you switch with a higher magnification objective. Okay, and so for your parfocal. Okay, for your parts of your compound microscope binocular, of course, you have your eyepiece. Your eyepiece, it magnifies the image. It further magnifies the image. Okay, for your eyepiece. Okay, and so usually it has a 10 times magnification again for this one. And then you have your objective lenses. Your objective lenses initially magnifies the sample at different magnifications. Okay, and so usually you have your scanning at 4 times, 10 times, 4 times, 40 times, and then 100 times. Of course, your scanning objective, your low power objective, your high power objective, and your oil immersion objective with red bands, yellow bands, blue bands, and white bands, respectively. Okay? And so, usually in a clinical microscopy, we make use of uh, your low power and high power accordingly. Okay, and then you have your revolving nose piece or your, yes, revolving nose piece. It holds your objective lenses for objective lenses. Okay, and so, and yes, it rotates for easy uh switching between your objective lenses. Okay, your condenser. This one focuses light onto your specimen for clearer to provide a clearer and sharper image accordingly. Okay, and then you have your light source. Your light source, it provides your light source, your light for viewing samples. Accordingly, it is usually a tungsten lamp. Okay, and so, or halogen or tungsten accordingly. And then your others, you have your stage, that is the platform where you place the slide for observation. And yes, it is usually equipped with stage clips or yes. Okay, and so to hold your glass lights or your specimen in place. Your X and Y access knobs for your stage controls. This allows precise movement of your slide. Okay, and so for your X-axis knob, okay, and so it will allow you to move your slide left to right, and then your y-axis knob, okay, and so it will allow you to move your sample or your specimen forward and backward. Okay, and then you have your course adjustment knob. It moves the stage up and down quickly to bring the specimen into rough focus. Okay, and so this one is rough focus. For your course adjustment knob, again, it moves your stage up and down. And then your fine adjustment knob. This one moves your stage up and down. This one is true of your electric compound binocular microscope. No? And then you have your fine adjustment knob. It makes uh, precise adjustments for your sharper and clearer image. Usually, your coarse adjustment knob is used with when you are using your low power objective, and then when you switch to high power, you make use of your fine adjustment knob, no? And then your arm, of course, your arm that provides stability and support. Okay, your body, it connects the eyepiece to your objective lenses, your body tube or your draw tube, is what they call your diopter adjustment ring or the adjustment. Yeah, yes, your diopter adjustment that is located in your eyepiece. It allows uh, individual focusing for each eyepiece. Okay, and so it accommodates differences in vision between the user's eyes. Okay, and then your light control knob. Your light control knob will adjust, of course, the brightness of your illuminator or the light source. And then your iris diaphragm, okay, and so controls the amount of light that enters your sample. Okay, and so for your iris diaphragm, again, controls the amount of light that reaches the specimen. And then finally, of course, you have your interpupillary adjustment, of course. Okay, and so this one is adjusted. Okay, and so to what they call this, to match the distance between the user's eyes. Okay, and so your interpupillary adjustment is seen in binocular microscopes. Interpupillary adjustment, this one is absent in, okay, and so in microscopes that are not binocular. Okay. Okay, your microscopy. Microscopy, again, that is your technique. Okay, and so all of the ones listed here are light microscopy accordingly. Okay, and so because they make use of visible light. Okay, bright field microscopy, it has a dark image of the sample against a brighter background. And yes, this one is used for routine urine analysis. Your phase contrast microscopy, okay, and so the variations accordingly in the specimen's refractive index are converted into variations in light intensity or contrast. Okay, and so areas of the specimen appear light to dark with halos of varying intensity. That is related, of course, to the thickness of the component. Okay, and so you have your thin and flat components produce light haloing. And yes, this phase contrast microscopy is ideal for viewing low refractile elements like hyaline casts, mixed cellular cast, mucus threads, and accordingly trichomonas. Okay, and also living cells, of course, unstained. Okay, that is for your phase con. Okay, this image here is from a bright field microscope. uh, And then this one is from a phase contrast microscopy. Okay, and so it made use of your phase contrast microscopy. Okay, and so please note you have a highly refractile fiber for this. Okay, okay. For your polarizing microscopy. This one accordingly illuminates the specimen with polarized light. And yes, it's used to identify and classify birefringent substances that shine brilliantly against a dark background. Again, this one is used for the identification of cholesterol in oval fat bodies, fatty casts, sorry, and crystals. Again, identity used and identification of cholesterol in oval fat bodies, fatty casts, and crystals accordingly. Fluorescence microscopy. This one is utilized for the visualization of fluorescent substances. It utilizes two filters. You have the excitation and the barrier filter. The excitation is to select a specific wavelength of light that is absorbed by the sample, and the barrier is, of course, to transmit the different longer wavelength emitted from the sample to a to the eyepiece for viewing. Again, fluorescence. Again, your atom absorbs light and emit light at a longer wavelength. Okay, and so this one is the same. It's the same principle with your chemistry. Okay, and so yes, the fluorophore that is present in the sample, the fluorophore is either natural or added, determines the selection of the filters. Okay, this one is an image captured from a fluorescent microscope. Okay, interference contrast microscopy. Accordingly, difference in your optical light paths through the specimen is converted into intensity differences into the specimen image. It produces accordingly a three-dimensional image of high contrast and resolution are obtained without haloing. Okay, and so you have your two types. You have your modulation contrast and differential interference contrast. Okay, and so for your Nomarski, that is the differential interference, and your Hoffman, that is your modulation. Okay, and so image obtained from a interference contrast microscope. And then finally, your dark field microscopy. Your dark field microscopy produces a magnified image that appears brightly illuminated against a dark background. Okay, and so special condenser accordingly presents only oblique light rays to your sample. And this one is used on specimen preparations. And yes, the preferred technique for identification of spirochetes or your Treponema pallidum. Yeah, okay, and so that is an image, okay, obtained from your dark field microscope. Okay, and so care of your microscope, you always use lens paper on optical surfaces. Always use a commercial lens cleaner to clean the optical surfaces. Accordingly, protect the microscope from dust when not in use. Of course, you cover it. And then avoid it temperature extremes and direct sunlight. Okay, and so of course, never place it in the refrigerator or in the freezer or don't expose it to sunlight. Document all cleaning and maintenance and have the microscope professionally serviced annually. Okay, and so with that, never use gauze, facial tissue, or lint-free tissue on lens surfaces. Never touch the optical surfaces with fingers or hands, and never wipe off dust or particulate matter. Never wear mascara while performing the microscopy. Never clean the back lens of the objectives. Never use grease or oil on mechanical parts. Never disassemble the microscope for repair. Please make a call or you call the representative. Never leave the microscope tubes without eyepieces. Insert dust plugs as necessary accordingly. Again, okay, and so you check the light source, the condenser alignment, and objective lenses. Okay, and so yes, inspect your mechanical stage movement. Also, define in course adjustment knob. And yes, you cover your microscope when not in use. Okay, and so yes, okay, and so annually again, perform or have the microscope serviced by a professional. Thank you and see you around.